that they need to become part of the climate solution. When we discuss climate change, it is often through an anthropocentric or human-centered lens. We ask, how can people weather climate change in the future? And how is climate change going to shape our societies? These are extremely valid questions, especially considering we are people. We're going to frame these questions in a human way. But there's an important perspective that I think we're not talking about here, and that is the topic of today's panel. It is climate change in the context of plants. So, thematically, this discussion is going to be broken into two pieces. In the first, we will be laying the groundwork for this climate discussion. What factors are driving climate change? How are ecological communities going to be affected? How are natural landscapes going to change in the future? Second piece, we will start to discuss more of the big question that I'm sure is on everyone's mind. What can be done about it? Adaptation and mitigation will be at the forefront of this part of the conversation, and this is the point where our expert panelists will share means by which positive climate impact can be made in their respective fields. Towards the end of the discussion, we'll have a chance to answer some Q&A questions that were submitted online. All right, let's get started. We'll kick off by having our panelists briefly introduce themselves and their work, and if they're inclined, share a personal or professional interest of theirs. We'll start with Sean Birkel here.
Well, good afternoon, everyone. I'm Sean Birkel. I am an assistant professor at the University of Maine, and I have a joint appointment between the Climate Change Institute and Cooperative Extension. And my expertise is...
Speak up a little bit.
Okay. Can everyone hear me?
No, louder. You can take it out, Sean. Take it out.
Okay. I can also try to speak for my diaphragm a little more. My background is in climate variability, climate modeling, and also as a graduate student, I studied ice ages and examined the last glaciation of North America. So my work spans a range of timescales, but of course, more recently, last several years, I've really focused on understanding Maine's climate, Maine's changing climate, and impacts. And I don't want to belabor this for too long, but I am very fascinated with North Atlantic climate variability and how it impacts Maine. It's one of my central themes.
Hi, everybody. Can you hear me okay?
Yes.
Great. My name is Hannah Mullally. I work for the U.S. Fish and Wildlife Service in the Maine field office. Our office is near Bucksport in East Orland. But my program is the Partners for Fish and Wildlife program. So I work with private landowners, land trusts, tribes, municipal governments to complete voluntary habitat restoration. The program focuses a lot on threatened, endangered, and at-risk species and their habitat restoration. That does include pollinators as well. So I personally have a big background in pollinator studies. That's what I did my master's thesis on, and continue to have a big interest in pollinators and native plants today too. So that's what a lot of my work focuses on, but I also help folks do a wide range of habitat restoration projects, looking at in-stream habitat restoration for our cold water fish species, and turtle nesting habitat restoration, things like that. Happy to be here today. Thanks.
Hi, everyone. My name is Sean Horan. I am the Climate Smart Agriculture and Forestry professional at the UMaine Cooperative Extension and the Natural Resource Conservation Service, which is a mouthful, but I just usually say I'm the Climate Smart guy. My background is in environmental engineering and forestry with both agencies in this partner role. I do a lot of landowner outreach and education, running workshops, but it runs the whole gamut. I do forest education with little kids all the way up to site visits with landowners, and also talking about NRCS programs and helping out the field offices across the state in a forestry capacity. And on a personal note, I always like to lead with favorite tree. So currently my favorite tree is the American beech, just because they have a pretty bad run of it right now. So they need someone in their corner. So I'm happy to be that.
Yay, Beechwoods.
Hi, everyone. My name is Andrew Tuffs. I'm the program manager of Bring Nature Home at Maine Audubon. And that program is it was inspired by the book written by Doug Tallamy, Bring Nature Home. That's all about habitat restoration with native plants and restoring and rebuilding Maine's natural biodiversity. In particular, we have a small native plant nursery at Gilson Farm in Falmouth, and we have a small plant sale that we run every year. And a lot of the work that we do is education focused, working with different schools and communities around Maine on trying to bring more native plants into our communities, into our backyards, and into our public spaces. So happy to talk more about that later. On a personal note, most of my time outside of work is spent with my 8-month-old daughter at Annika at home. So looking forward to getting back to her today.
Hi, I'm Rebecca Long. I'm the agriculture and horticulture professional for University of Maine Cooperative Extension. If you guys aren't familiar with Cooperative Extension, we're your door to the expertise of the University of Maine. So my work focuses on answering questions and putting on programs for farmers and gardeners in Oxford County. And as part of that, I've gotten the opportunity to do a lot of work around climate change and its impacts for farmers and gardeners. And my personal interest right now is restoring the habitat on my property. And I just got it pollinator friendly certified a few weeks ago. So I'm very excited about that.
Excellent. Thank you all again for being here. I'm Corey Kutfilla. I'm the horticulturist here at Mclaughlin Garden. And as I'm sure you know by now, I am the moderator for this discussion. So, kicking things off, we'll go down the line one more time. And I'd like each panelist to mention something in their field that they're especially worried about as far as climate change goes. One of their kind of biggest concerns going forward. Yeah.
But before discussing what I see as the biggest concerns, I just wanted to give a very brief overview of climate change in Maine. If we look at changes over the past century, in relation to greenhouse gas warming, and in the earlier part of the 20th century, there was natural variability involved as well. But by mid-century, the warming has been absolutely dominated by greenhouse gas emissions in the response. Maine's climate has warmed on an annually by about 3.5 degrees Fahrenheit, which might not seem like much, but that translates into a shift in the relative length of winter and summer, as well as less warmer winters, warmer summers, and also a shift in the length of the growing season. And so to bring this back to plants, whether it's agriculture or gardening, I think we've all seen over, especially the last 20 or 30 years, a significant change in the growing season, increased variability as well, less predictable fall in particular. And so in the context of the growing season, its impact on plants, there are certainly concerns for, as the climate warms, changes in what types of plants will be suitable for growing here, both in garden context as well as for agriculture, and then as well as southern species moving in and northern adapted species to migrating north. Forests will take time to do that, of course, because most tree species have long lifespans. But Maine's landscape and the plants and the environments that we see will shift over time, and we have seen those shifts begin. And I also want to mention precipitation. That's a significant issue in terms of we're seeing more heavy precipitation events, more erosion. And in this past year, especially, I think we've all been impacted in one way or another by heavy precipitation events causing flooding, road damage. infrastructure damage, difficulty accessing fields and crops. Last summer, there was a big problem with plant rot and different diseases from just being so wet. Last summer was the second wettest growing season on record. And we'll see what the remainder of this season brings, but now I'll pass this along.
Yeah. So for me, in the context, especially of habitat for wildlife and threatened and endangered species, I see a huge connection with loss of habitat and climate change. So whether it's loss of habitat through man-made destruction, completely demolishing habitat for development or other, things that don't really contribute too much to wildlife habitat value, or invasive species encroachment too, which I could see being a larger problem with climate change in the future, as species that are much more adapted to kind of a longer growing season, hotter conditions, kind of moving upwards and displacing some of our native plants too. So just all around, I think the loss of habitat would be, I think, my biggest concern.
All right, and outside of the current heat keeping me up at night, what keeps me up worrying in a climate change sense is just the variability, especially looking, as Sean said, in a temperature and precipitation front. Those are kind of singular causes, but they can have a lot of effects. I recently heard Dr. Ali Kasiva at the University of Vermont use the term climate change as a threat multiplier. So trees are very resilient, but if stresses pile up over time, those stresses can affect the tree longer term than if they would individually. So these individual causes can have multiple effects, and the uncertainty in that, and just the amount in which they multiply those threats, that's the kind of scary part in my opinion.
Yeah, I guess I'd add on what both of you have just said and say that it's probably what keeps me up at night are combination of invasives and then also habitat loss. And thinking about the threat multiplier, I guess where I grew up along the mid coast, I've seen a lot of large oaks come down in recent years, and I think of an oak, really, really old oaks that have withstood storm after storm, and now in these areas where we have things like brown-tailed moth and winter moth that are defoliating the trees year after year, combined with these really intense storms and drought and prolonged droughts, and then seeing them start to come down after all these threats on top of one another. So that's a big concern, especially when we think about oak trees being the number one keystone species and hosting the most caterpillars here in North America. So that's a species of the utmost importance. And as far as invasives go, I just think we're seeing more and more, whether it's insects or pathogens or other plants that are coming into landscapes. And as someone who's trying to connect more people to nature, that's something that can often bring out fear and make it that much more complicated to know how to manage a landscape. And so I just want to make sure we find a way to not let invasives create that much more of a barrier to connecting with nature.
Coming from the perspective of farming and gardening, I think the big difference is mostly we've been talking about native ecosystems, and farming and gardening is inherently like a managed thing. And the problem with climate change is that it's increasing that management complexity. So for, all our standby varieties and planting dates and practices, even where we planted things might not work, and then we can adjust one year to drought, and then the next year it rains a bunch and it doesn't work. So I think for gardeners, it's really frustrating because things that used to work don't work anymore. And for farmers, it can really go into your entire farm viability if the management complexity is getting more extreme, and all the practices you have to start putting in place to deal with this take up more and more of your time. So that's really what worries me, is like how people are going to find the time to figure out how to manage all these changes.
Yeah, so it sounds like one common theme here is that landscapes will be changing as time goes on. On that note, I'd like to ask Sean Horan could you talk a little bit about how our forest compositions are expected to change in the future and what kind of modeling we're using to do that?
Sorry, what was the part of that?
What kind of modeling that we're using to make predictions about forest change, forest composition change?
Gotcha. So, as Sean alluded to and mentioned, Maine is this really beautiful mix of northern boreal species and kind of southern temperate species. So, a bunch of species are either at the southern extent of their range or the northern extent of their range. So these changes in temperature and precipitation are just going to exacerbate that. And one of the big changes that a lot of the models are predicting, talk louder, cool, is the boreal species kind of going back further north into Canada. So things like species like that we can consider balsam fir, basically all of the spruce species, birches, which are also kind of another northern species, tamarack, cedar. So a lot of our softwoods aren't as well adapted to the southern climate. That's why the southern extent of their range just dips down into New England and Maine in some cases, where some of the more temperate species that are slated to do quite well could possibly move in, and then those habitat ranges will expand, populations will increase for ones that are already here. So in a forest sense, in the longer term, the scale is kind of sliding into when we'll see that, because as Sean was saying, the trees aren't just going to pick up their roots and move. It takes time for these things to happen, but we are starting to see it. And in terms of modeling, there's a number of models out there. I really like to point people in my talking with landowners to the Climate Change Tree Atlas, which is a U.S. Forest Service online tool, and you can plug in individual species there. You can play around with it for hours. It's really interesting. You can plug in an individual species and it'll pop up their current range, and based off of a number of different accepted and widely used models and research, that you can see where they're expected to go, and also kind of what the outlook is for them, whether they're slated to do well, not do well, and why they're not slated to do well. Like example, white oak is slated to do really well. The oaks are slated to do well in a climate sense, but ones that are more prone, susceptible to drought or fire disturbance, like some of these softwoods are, that's one of the reasons why they're slated not to do quite as well. So it goes really in depth there. So in terms of a resource for folks, I think that that's a great way to kind of dig into some of the modeling. So I hope that answers.
What was the name of that, the resource again?
The Climate Change Tree Atlas. It's a U.S. Forest Service publication, and I'll make sure to send any resources I talk about to Corey, who can then spread it out.
Pass them out. Awesome. Would anyone else like to jump in on that? Okay. Alrighty. See, so Sean Birkel. So we had talked previously about the changes in the planting season for gardeners and farmers. That the spring and the fall seasons are kind of shifting a bit. Could you touch on that?
Well, the relative change in the seasons. And first, there are a couple different ways to define this. If I were showing slides, I would show a graph of the temperature annual cycle with each month on the x-axis, and then there's a sine wave that represents the change in temperature throughout the year. With, of course, in the wintertime, it is the trough of the sine, and then there's a peak in the summer. And then if you can imagine, in a warming climate, the sine wave is shifting up relative to a datum. If we use the 32 Fahrenheit melt freeze line as a datum, you would then see that the relative length between when the average temperature gets above freezing in the spring and the average temperature drops below freezing in the fall, early winter, that length of time has increased. Now the growing season, a measure for that would be more near, say, the 50-degree Fahrenheit datum. But similarly, there's a change in the relative length of the growing season. Now, over the past approximately 50 years, there's been about a 2-week lengthening of the growing season, and about 2/3 of that has occurred in late summer into fall. And so the most of that lengthening of the warm season has occurred later in August, in September in particular, the month of September has warmed significantly. I'm from Bangor, and I remember in the late 80s, early 90s, I remember it just being colder, more commonly on first day of school, for example, or in the month of September. If we look at the data, it's very clear that September has warmed a lot. And so in terms of degree day accumulation, that's important for plants. That has increased. And then, of course, the timing of the average first and last frost, but it's the latter part of the year that's more considerable. And just one other example. Last year, the May 18 freeze event, that was the latest season freeze. I examined a few temperature records going back several decades, and it appears as though that was the most severe late frost season event since the 1950s. I think since 1954. But in that same year, we saw a very late extension of the summer warm season. So we have to increasingly learn to manage this sort of variability. There can still be a late frost in the spring, and more reliably a warmer fall and an extended growing season. But there is still the risk of a weather event that can bring in early season freeze as well.
Sean, did you want to jump in on that?
I had really good notes that I neglected to use in my last answer. And when I looked up, I forgot something I wanted to include and mention upon. I know this is about plants, but I think another important component is our kind of relationship with these plants and how we either passively or actively manage our forests and kind of help, whether it's from a climate change sense or an economic sense or just a landowner objective sense. One of those changes, which Sean just went into detail about with the temperature, is as the temperature is increasing, the winter is increasing, from what I've seen, more than in some of the other seasons. So that's less frozen ground time, from a management perspective. Harvesting and working in the forest in the winter is the best time to do most of the time because the ground is frozen. So there's less harm to the ground, less soil loss from rutting and runoff. Also less damage to root systems and less clonal root suckering from things like beech and some of those vegetatively sprouting plants. So a shorter winter window means there's less time to do good management if that's one of your goals. So I think that's just another important change we're going to see from a management and kind of our relationship perspectives.
Rebecca, as a gardener yourself and someone who frequently interfaces with other gardeners and farmers, I imagine this shift in the seasons has quite an impact on those folks.
Yeah, and it's interesting because I've gotten in trouble before for saying this is not all bad, but like the reality is a longer growing. I mean, one of the challenges in Maine is our short growing season, so there are ways in which a longer growing season could allow us to expand to varieties and crops we haven't before. But the problem is like this late frost events. The increased variability means we have things happen where the blossoms on peaches start to expand because they get a little bit of warm weather. Then we get this frost, and that's why we had no peaches in Maine last summer. So it's almost more like the variability of like some warm and then really cold can really impact blossoms. So I think that's where I worry is the impacts on crop, their natural cycles. And for gardeners, we are going to have to look at the times we plant and maybe delaying, because of this risk of late frosts. Maybe we're looking at planting later, and because, as Sean alludes, we're having longer falls, maybe plant varieties that will go a little later in the fall. But also there's going to be no typical year, so trying something in 1 year might not work in the next year.
So it doesn't sound like for crops it's necessarily a difficulty, but as far as for native plants, Andrew, would you be able to speak on how they are dealing with this lengthening of the season?
Yeah, I can say as far as So like planting projects that we've done last year compared to this year is a great example of the variability that we're facing. Last year, we were able to plant trees and shrubs basically all season long without an issue, with doing minimal watering. It was pretty ideal actually for establishing plantings, whereas this year is a little more typical of what we'd seen in the years prior to last year, with droughts and really increased temperatures. So I think it's really just that variability. I'd say as far for natives, if you are growing native plants yourself and you're sowing them from seed, you might know that they require very specific germination routines, and that we're seeing could be affected by these shorter winters. And so that is something that we're watching. And I don't have a great answer on yet as far as what is affected. Though I assume that some species will respond much better than others based on their germination requirements. But yeah, I think basically just being ready to respond to the weather patterns as they come about every season. For generally, when it comes to native plant garden installations, watering is the big thing that we're thinking about.
Hannah, would you be able to speak on the pollinator aspect of that? Because of course they have an intrinsic relationship with those native plants.
Yeah. So something that comes to mind a lot with our native pollinators and native plants is the fact that there are many bees, in particular in Maine, that are specialist bee species. So that means that they require, they only feed on pollen from maybe one genus. So maybe a few different species, but one genus or maybe two genuses. And they emerge kind of in the past at the same time that those flowers would start to bloom. So they're timed very well. A lot of our bees only are active 3 to 6 weeks as adults after they emerge in the spring or in the summer. So if there's a mismatch, then if some of the plants start to maybe bloom a little bit earlier or a little bit later, or maybe perhaps because of the warming weather, the bees might emerge a little bit earlier. That could have a severe impact on those specialist pollinator species in particular, when they just wouldn't have the food available that they would actually need. So for generalists or for specialist pollinators in particular, that could be a huge issue. Generalist bee species that feed on pretty much anything that's available probably won't have as hard of a time. Although the rusty patch bumblebee that is listed as endangered is a generalist bumblebee species as well. So that probably wasn't a fact of their host plant or something going away, other factors, but just to say that specialist bee species could be hit pretty hard with changing phenology of timing of flowering or emergence, but generalists could also be hit kind of hard too, especially when it comes to maybe some invasive plant species, pushing out some of our native plant species that all of our native pollinators are very used to. And then also talking about pollinators other than bees, we also have things like butterflies and moths in Maine. Those also contribute to pollination, but the interesting thing about butterflies and moths is that in their larval phase, in their caterpillar phase, they all have host plants. They have to have their eggs laid on, and then they emerge and as caterpillars eat sometimes very, very specific plants only. So a great example that a lot of people know is the monarch caterpillar, monarch butterfly. They only lay their eggs on milkweed, and the caterpillars exclusively eat milkweed. So if milkweed disappears, we wouldn't have any monarch butterflies up in Maine. The other example is the Carner blue butterfly as well, that feeds exclusively on, in its caterpillar phase, on sundial lupin, our native lupin in Maine. They don't feed on the big leaf lupin that you see mostly throughout Maine now. And we don't have any Carner blue butterflies even in southern Maine anymore. So that's a pretty prescient example of a host plant disappears and the butterfly disappears with it.
One thing that I've personally noticed is in the past couple of years, at least, the snowpack during winter has been less significant. Uh, Sean, would you be able to speak on that? Whether there's correlation between climate change and a reduce in snowpack?
Yes, absolutely. The warming winters, especially in the southern half of the state. There are three climate divisions in Maine: the coastal zone, and then a central climate division that runs parallel to the coast and extends inland to about Lincoln or so, and then a northern climate division. And when we look at snowfall records across the state, so for example, Portland compared to Caribou, there's a considerable decline in snowfall and period of snow cover in Portland. Caribou has actually increased. There's actually an increasing trend, although that was not true this past year. There are some years in which, because there's such a steep temperature gradient, the difference between the southern and northernmost part of the state in the wintertime, that even during a warm winter, there can still be abundant snowfall, say north of Millinocket. Whereas the southern half of the state more consistently is getting midwinter rain events and less reliable snow cover. But then, of course, there are very warm winters, such as this past winter, in which the entire state saw very low snowpack. And so it's, of course, both the total amount of snow that falls in the winter and whether or not there's a late onset of snow or early snow melt. But overall, with the exception of this interesting situation in the northernmost part of the state, the snowpack is declining, and especially there's in the springtime we're seeing earlier snowfall and of later onset. That also correlates with change in ice cover on lakes, which I think most of us have seen lakes that 30 or 40 years ago would ice up in late November, early December. Now might not ice up until 1st of January or so.
Just about pollinators and snowpack too. A lot of our pollinators and a lot of insects in general nest either burrowed under the ground, just a little less than a foot or so, or just in leaf litter. And they really rely on the insulation that snowpack provides to keep them alive throughout the winter. So what happens if we don't have snow, a good healthy layer of snowpack, if it's bare ground and then all of a sudden we get a hard freeze, those insects in their larval or egg form, even sometimes adult form, might just freeze and die. So that's another kind of something that I don't often think about to bring up, but there's a lot of things that rely on the snowpack that live in Maine.
And just quickly, Sean Birkel, could you define the difference between climate and weather? Because they are two very different things. I think it's an important distinction.
Well, I like to use the most basic definition of climate is that climate is average weather. And as climate warms, that inherently implies that weather will change in some way. Those changes are more or less measurable depending on the time scale and the variable we're looking at. But weather is what you see day to day, high pressure system or storm system. But the average of storms affecting an area or the average temperature over typically multiple decades, that's where we start to define climate. In some contexts, there's also short-term climate. NOAA, for example, has seasonal climate outlooks. But when we talk about climate change, we're thinking on multi-decade, century scale. And historically, the World Meteorological Organization and NOAA have identified climate normals as being a 30-year period average. There's discussion now, though, because the climate is warming, it's in what we would call a non-steady state, that maybe the 30-year normal doesn't make sense because a 30-year average going all the way back to the early 90s now, the early 90s was quite a bit different than even just 10 or 15 years ago. And so that's fundamentally the difference between weather and climate and in the linkage.
Yeah.
Thanks.
Excellent. Thank you. Let's do another definition to transition to signify the thematic transition of this talk. Rebecca, would you be able to talk about mitigation and adaptation?
Yeah, so you may see on any article or poster about climate change the words mitigation and adaptation, but they actually mean two very distinct things. So mitigation are ways in which actions we take to stop or slow climate change. So things that reduce emissions and reduce the concentration, or at least stabilize the concentration of heat-trapping greenhouse gases in the atmosphere. So example, say some municipality switches all their public transportation from diesel to a renewable energy source that reduces emissions. That would be a mitigation because less emissions means less greenhouse gases in the atmosphere, slowing climate change. And adaptation is something we do to deal with the climate change that's already happening, the effects of it. So it could be the effects that are currently happening or happening in the future. So an example is a farmer installs an irrigation system when they never needed one before because they now can't count on enough rain every year. So it doesn't do anything to stop climate change, but it's how they adapt to the impacts. So mitigate, slow climate change, adapt is just adapt to it. And they overlap a lot. A lot of practices do both.
And being in a partner role with NRCS, I'd be remiss if I didn't also kind of mention, we were talking about this previously, the NRCS part of USDA, the federal government, is right now they're focused on mitigation as their primary concern. So they've identified activities that reduce greenhouse gas emissions and either store or sequester carbon. So going to those kind of mitigating side of things. But that doesn't mean that a lot of those things don't have co-benefits, especially in the adaptation side of things. So just because the terms are different also doesn't mean that they can kind of be married together to have a lot of benefits. And going back to the threat multiplier, climate change being a threat multiplier, that's kind of another shining light, is that these things that we're doing, whether it's for mitigation or adaptation, they do have multiple different types of benefits a lot of the time. So combating some of those multiple different types of changes. So a little kind of like ray of light in there.
If you're wondering, like, how could something do both? So say you, as a gardener, put down compost. Compost is mostly carbon. So the more you build up your carbon in your soil, you're sequestering carbon, which in other forms could be a greenhouse gas, but also organic matter retains moisture in your soil, retains nutrients, but also creates structure that allows the soil to drain better when it's too wet. So you're sequestering carbon, which is a mitigation, but you're also adapting because you're making your soil better to more resilient in the face of either drought or flooding. So that's an example of like something that would be doing both at the same time.
All right. I'd like this point to be kind of an open discussion about which tactics for mitigation and adaptation each of you use. But can we start with Andrew? Can you tell us a little bit about what kind of strategies you use at Audubon to mitigate and adapt?
Yeah, so I would say one project we've worked on, if you've been in the South Portland area before, Willard Beach, it's experienced extreme erosion. That whole area has with coastal storms. The dunes there have undergone a lot of pressure, and the dunes, as of a few years ago, were completely overrun with rugosa rose, and we've gone in and replanted with a mix of bayberry, beach plum, dune grass, and a variety of other species. And that's and it's held up really well even with these storms recently. It's in a spot that is it gets such high traffic that we have a ton of signage up around it, and it's worked really well as an inspiration for others who might also live along the coast as ways to adapt and try to restore some of the biodiversity along the coastline. Otherwise, I would just say planting native plants and trying to restore and enhance biodiversity in your own backyard
is one measure that really cannot be overstated how effective it can be.
Hannah, so you do some planting in riparian zones.
Yep. Yeah. So the riparian zone, for folks who aren't aware, is the zone it's the transition zone between kind of like the upland area that barely ever gets flooded, and the river or the wetland or the pond. That kind of zone in between is the riparian area. So through my program and with a lot of partners, we do plantings in riparian zones that have been, in some cases, farmed right up to the edge of the river. In other cases, just like the riparian zone is invaded with a lot of invasive species, with invasive plant species, just kind of in not good shape. And the reason that we do that is because pretty much all of our native fish in Maine need cold water at some point in their life cycle. So if you can imagine, if you had a pool in your backyard that was shallow and just in the middle of your yard with no shade over top, it would warm up really, really fast. So when we're planting riparian buffers, what we're looking for, part of it is to shade the river or the wetland or the pond that's there for the aquatic life that's in that in the river, but also for stabilization too of the banks. So as we're getting a lot more intense rain events too, we're seeing more erosion happening. Plants are just kind of the edges of the rivers falling into the rivers. Rivers do naturally meander and change course a little bit, but sometimes it can happen very quickly now, especially with our intense rain events. So planting riparian buffers also helps to stabilize the soil and to stabilize the banks a little bit more too. And we plant native plants as well because, again, it's just another asset to all the insects and all of the wildlife that utilize riparian areas, not in the water, but just as a terrestrial zone as well. So many different species utilize that riparian zone at some point in their life. So it's really important to restore with native plants too.
So, oh yeah.
In my work as a state climatologist, I provide climate and weather data to help facilitate decision making and planning. And so that interfaces very much with the adaptation side. And so, for example, adapting to for a given area, the climate that's projected out in the next 30 or 50 years. And also identifying the unknowns and the uncertainty associated with that. Because there are many issues in which there needs to be a cost-benefit analysis. What are the risks? What is the uncertainty? And what are the costs of taking one adaptation measure versus another? So that's part of what I do. And to that note, I'd like to mention I'm also serving on the Science and Technical Subcommittee of the Maine Climate Council, and we've been providing the baseline data for climate change in Maine that then goes to working groups and then ultimately the Maine Climate Council to develop Maine's climate action plan. So there's a adaptation and mitigation are both involved in the planning, but primarily my area is facilitating decision making and providing data for adaptation.
We've mentioned a few times now that as it gets warmer, we're going to have plant species moving north. So there is also a strategy that we can use to speed up that movement of species and plant things that will survive better in the future by planting them now. Could we talk a little bit about that? The assisted migration.
Yeah, so before I jump into the assisted migration thing, I just want to back up a tiny bit. As mentioned, I like to boil down a lot of the adaptive strategies into one word: complexity. I think that's a really important component, building heterogeneity into our forests, and that can come in a lot of different ways. Structurally, if we're looking at it from a landscape scale, that can be trying to mimic natural disturbance regimes that are existing in Maine. So like small wind throw events, whether that happens naturally or management wise, creating little thinnings of single trees, or larger disturbances like root cuts or patch cuts, creating those on a landscape scale, those different pockets adds heterogeneity and provides for different species to come in, because some like different amounts of shade, some like different amounts of density. So that's one type of structural complexity. Looking vertically, having complexity and the amount of the canopy, the mid-story, the understory, the forest floor, having a lot of variety in that vertical structure is also a really important component of adaptation. And then switching gears to compositionally, which is part of the assisted migration, complexity in the species composition. So tree species, herbs, shrubs, having a variety, not just a monoculture, or even aged, like single age species, like after somebody clear cut or something, a single age coming in, a variety of species. So complexity in that, and also temporal complexity, maybe not managing or doing your work at the economic rotation age or the biological rotation age, going in every 15, 20, 30 years, extending that or adding some variability in that. So just baking in complexity into our forests, we can help do that. So if a new threat does come in, or these changes keep happening, there's a wide variability in that. Our forests are adapted and not just all the eggs in one basket, kind of cliche. So I think that that's an important component. And now to the assisted migration component, that's essentially human-assisted migration of species in the face of climate change. And climate change, species historically we've seen over time, you can see maps, see how different species have chased moisture regimes or precipitation or temperature changes over tens of thousands of years. Climate change is moving at a rate where some may not be able to do that, or will have a harder time, especially with how we've kind of segmented up a lot of the landscape. Some of them might not be able to make those transitions, especially if they're like a harder masting species and their seeds can't, move a quarter of a mile at a time in a gust of wind. So there are three different types I wanted to mention. There's the assisted population expansion, assisted range expansion, and then assisted species migration, which is the bigger one, or the kind of the hot topic one. So population expansion, you can imagine in a species given habitat range, basically just planting more species that are already there, already in their native range, whether it's changing genetics or increasing density of the individuals in the forested setting. It's basically buffering up the existing population in an area where they're already suited. Range expansion is kind of thinking if you're just tossing the species right over the line of their habitat expansion to where they may have suitable habitat, but it's really not lifeboating them and moving them well outside of their range. It's more just kind of helping move the range of the habitat expansion up or west or east or south. And then species migration is kind of the interregional, intercontinental moving of species in advance of climate change. And an important component of all the kind of the latter two is finding species that can fill functional traits of ones that we're expected to lose, like beech, for example, with some of the pests and diseases. Beech leaf oaks are going to have a larger component, so those hard mass species is just an example of red oak's already here, and white oak as well to a certain extent. But finding that's just an example of a species that fills a really important hard masting, really high calorie dense nut for a lot of wildlife, filling in a species that we think can fill that functional trait in a forest setting. I think is just a important component of assisted with species migration or expansion or range expansion. So it was a little long-winded, but I think
it's perfect. So, and this can be a question for anybody, but so assisted migration, we're moving plants that we expect to do well. What about the plants that we do not expect to do well? Say the small world begonia. Is there merit in trying to bolster populations of plants that are not predicted to survive or are currently struggling?
try to answer that because I think it really depends on the species, definitely. So within the Fish and Wildlife Service, the small world pogonia is federally listed as threatened. There's another one up in northern Maine, Furbish's lousewort, that is listed as endangered. And a third one that we have, eastern prairie fringed orchid, in one spot in Maine. It's the only place. So we are desperately trying to find a way to do some sort of propagation, spreading it, essentially in a small scale assisted migration to different, maybe it's probably range expansion would be the better term of it. It can be really difficult. I don't think that it's necessarily bad to try. I think that there's a lot of unknowns, especially for plants, especially things like orchids that have like a really complicated relationship with fungi and certain funguses that may or may not be available in the new site. So I think it could be worth a try if especially if a plant is in dire need, and this is maybe Maine might be the only place in the world or in the country where it is at currently. But I think it'll be difficult though. Anybody else want to chime in?
It's actually just out on a small world begonia survey this week, so that's an interesting tie-in. But in the forest setting too, I think I heard someone mention or say this before, and I thought this was a great example. We don't want to kind of create our own self-fulfilling prophecy of if the species is slated to not do well, whether it's a tree pest or disease related and worried about losing a whole species, like ash, for example. If we go down, or if we just kind of swear it off or preemptively try and salvage what's still good in there, we will be losing that component kind of from our doing as part of one of the factors. So not swearing away something just because a report said or findings indicate that the species might not do well doesn't mean that's covering a very wide swath of the country or the whole country in some cases. So I think that while it's important to be aware of these changes and what species may or may not do well based off of their ecological traits, it doesn't mean that we'll lose them all necessarily. So yeah, on the brighter side, I guess.
Well, it looks like we've got a question. So
Yeah. Yes. Hi, Jim Skinner, Thompson Lake Environmental Association. And for any of you here may know, we are collaborating with Mclaughlin Gardens to help build better, more robust and powerful buffers on lake shores, particularly Thompson Lake. There's a question that I'm interested in. I just learned, of course, I knew about pollinators, but I just learned in putting together native plant programs and availability. I learned about Audubon actually has a program where they identify native plants that actually help feed via the larvae of certain insects, the birds that need larvae for fledgling to put the worms in their mouth, plus the seeds later on to migrate. So I'm wondering, is that part of this conflict of bringing new, because I don't think anybody I know has ever heard of the difference between pollinators and whatever you might call that characterization of native plants that feed birds. And if you look at that as a mix, and you go to a garden place that has native plants, and do you want pollinators or do you want to feed your birds and attract birds to your land? How do you make a choice there? Or if you decided all feeding the birds, then are you going to then discourage the pollinators, plants and whatnot? The bigger question that I have, I'd just like to throw it out, is how do we, and Rebecca, you may have something to say about this, is in lieu of all the needs that we have and in all of the tools that we're now developing, do we have a way to help plant these plants, not in the summer, but in the spring and in the fall when the weather is more better for those plants to survive, when we need planters? And I'd like to address that fact that volunteers in various ways, I'm trying to get a consortium together that might include AmeriCorps and whatnot, and the Maine Climate Corps, through some sort of coalition to be able to supply perhaps garden clubs that you have to volunteer their time to do field exercises and plant on lake shores. So that's I could go on for a little bit more, but I think I threw out a little bit of interesting topic. Thank you.
Thank you, Jim. All right.
Yeah, so great questions. So to your point about trying to choose plants to support birds and that would support the feeding of their young and then also supporting pollinators, hopefully at the same time. I think you can do both. Lots of plants that what birds are typically feeding to their young are a lot of caterpillars. So the things that I was talking about of caterpillars needing a very specific host plant to feed on, that's what the birds are going after. So a lot of those species, it might be something like willow. Actually, willow supports a ton of caterpillar butterflies and moths that lay their eggs almost exclusively or partially exclusively on willows for their larval feeding habits. So great for the birds. There's going to be a lot of caterpillars on willows. Willows are also one of the best pollinator plants that you can plant too, because they bloom so much earlier than a lot of other species too. So that's an example of one sort of plant that can really do both. And I think a lot of plants are like that as well. Some things like oaks, you don't really think of as pollinator species per se, but they do provide great larval foraging habitat, I guess, forage for a lot of different species of butterflies and moths. But bees still are found to actually visit oaks as well, too. So it's not a total wash, I don't think, for what you don't have to choose one or the other. Yeah.
Yeah, and I just add that I think the nursery industry has jumped onto the pollinator craze and used it as a marketing opportunity, right. And that's why we see it on a lot of plants at nurseries saying pollinator friendly. But generally, if it says pollinator friendly, it's probably bird friendly too. Taking it one step further, I'd say just looking for keystone species, so species that support the widest array of insects is a good way to go. That's going to support ideally both pollinators and birds and other wildlife.
Might you address plants that are more suitable for buffers, which is a quicker aspect than thinking about trees that would take time to prosper?
For buffers?
Buffers.
So like shrubs?
Shrubs and plants that would go on in that riparian
area
to stop erosion, collect water, prevent phosphorus from going into the soil, into the water.
Sure. I'm happy to name a few. Just as far as overall genus, dogwoods, shrubby dogwoods, Sweta are great. Viburnums, willows, as Hannah mentioned. As far as erosion control, other things like deer villa are really, really great. Sweet gale, if it's around a lake, it's another good one in the Morella family. Yeah.
Thank you.
I want to add that I think we tend to put bugs into different categories in our head, like good pollinators, and then there's like bad bugs. And the reality is that it all depends on context. And I think like one thing I think about a lot is we plant milkweed for the monarchs, and inevitably every year I get a call from somebody who's panicked because something else is eating their milkweed. And I ask what, and they send me pictures, and they're other native insects. So monarch and milkweed have become so like synonymous and symbolic, but the reality is milkweed supports tons of native pollinators, which are caterpillars that birds can eat. So it's really a system where, and also there are besides bees that pollinate, there are beetles and there are flies. And so the system is really quite complex and things serve multiple roles. So a pollinator can also be a bird food. So, if you have a ton of milkweed and you get a ton of caterpillars, the birds are going to eat some of those, but there's going to be enough to survive to also continue the population and feed our birds. So I think the reality is when you plant natives, you get all of it. And talking specifically about the industry, I think a couple of things to keep in mind. Before we even get to the point of needing the labor to plant the plants, we need the plants. And the nursery industry is for sure catching on. I just went to one this past weekend and I was amazed by how much. But a couple things to be aware of is what they're putting on those plants. So neonicotinoids are a systemic pesticide that's really popular because you can throw it in the soil in a nursery and it gets in the entire plant and it protects the entire plant from getting eaten by bugs, and plants look great in the nurseries, but those make it into the pollen and the nectar and are terrible for pollinators. So if you are going to buy a plant to plant specifically for the habitat, you should be asking the question, what have you applied to this? And chances are, if you're buying from a big box store, there's a good possibility that there are pesticides on there that can negatively impact. So when you buy your pollinator plants, asking what they've applied to them. And the other thing is looking at, something can be labeled pollinator plant, and it doesn't actually mean it's native to Maine. So one thing I see really universally is the pollinator seed mixes. If you see a pollinator seed mix and it's not specific to a part of the country or a condition, it probably contains non-natives, because there's no one wildflower meadow mix that would be native to our entire country. So if it doesn't say for the Northeast, then it might not necessarily be suited. And same thing within a nursery, it can say a pollinator plant, but that doesn't necessarily mean it's native here. So showy milkweed, for instance, is a gorgeous milkweed that is not native here. And they've actually found that if planted in the wrong region, it can delay monarch migration and actually decrease survivability of those monarchs. So making sure that it's not treated with pesticides, it's actually native to Maine, and the top tier of a pollinator plant is a local ecotype. So there are plants that are native to huge swaths of the country, but there can be ecotypes that are slightly different in different parts of the country. So if you can find a place that is collecting seed from your ecoregion, from New England, and growing those out, those are going to be the best, for planting in your area if you're really trying to mimic a native habitat. And the last thing I'm going to say really quick, nativars. So a cultivated variety, a cultivar, is something that has been in some way adapted by humans. And so a nativar is a cultivated version of a native plant. So if you go to a nursery and you see this echinacea that's a crazy color and double bloomed, that's a cultivated echinacea. They're still doing studies to determine the impacts of those cultivated varieties on pollinators, but early work and things done at Ptolemy have indicated is that if it significantly changes the way the flower looks, the bloom time, the size of fruits, those might mean they're not going to work as well. So if the fruit is all of a sudden way bigger, the beaks of a bird might not be suited to it. Or if it's flowering at a different time, that, as Hannah mentioned, the pollinators might be not emerging at the right time. And then the way pollinators see is totally different than us. So if it is a different color, they might not be able to find it. So not to say you can't plant these things at all. If you have some crazy echinacea that you love, that's fine. But if your goal is specifically planting it for the pollinators, getting as close to what we call true species, which is what would exist in nature, is the best case scenario.
Just add one thing on the neonics in soil of container plants. If you get a plant from a nursery and they don't know, if they've ordered the plant from somewhere else and they can't answer whether or not there are neonics in the soil, for one, don't get it. But also, if you just get a plant and you want to be extra safe, you can bare root the plant once you get it and wash the soil off down to the roots. And that's also just another way to take precautions with other invasives that could be brought in on the soil as well.
Thank you. Rebecca, could you address the labor aspect I mentioned? You run groups of teaching people to work in gardens, and that's where I'm pointing at.
Yeah. I think the more we can educate people about the importance, the more volunteers we'll get. But honestly, ultimately, if there could be legislative policies that put funding towards that would be best case, which is a great transition to what I wanted to say about mitigation specifically. We've talked a lot about what the individual can do, and I think it's really important to state that ultimately the things driving climate change are at an industry and the national level. So I think it'd be remiss to not talk about the importance of policy. And so if you're serious about climate mitigation, finding a group that keeps track of legislation in your area and sends you a newsletter and says, hey, call your legislators, call your congressman about this specific bill. I think that's really important. And so in all of this, I don't want to miss that is a huge piece of this, and that there's no matter how many of us switch to electric mowers and stuff, ultimately, if industry is not being held to the same standards, it's only going to make so much of a difference for mitigation. So that kind of goes back to my point of the more we can educate, the more volunteers we can get. But ultimately, if we could get federal money towards this, and we can actually pay people to do it through programs like AmeriCorps and things, that would be even better. Not a short-term answer.
And really quickly on the nursery note, changing gears a little bit, so I wanted to wait until all your questions are answered. In the forest setting, there's a little bit of a different issue, and this is more of a human issue. And this plays into the assisted migration part, is the lack of nurseries for forest species, for tree species. I think in one report I was reading, there's just one in New Hampshire and one in New York. So that not only limits where you can get a variety of species, but also the genetic stock of those species. So that is just kind of a logistical problem. You have to go either really out of your way or can't find what you're looking for at all. If you wanted to maintain local genetics in Maine for some of the species, that can be even harder. But it just makes it more difficult. A few great places are like soil and water conservation districts to go to ask, maybe from a plant sale, or if they have any connections, district foresters. Sometimes they get stock from different industry and have just a bunch of spruce. I know one of the district foresters down east gets spruce stock and then hands it out to whoever wants it and knows it's going to plant it. It's going to do well. So there are options out there. They're just not as widespread and numerous. You have to do more digging, but there are ways to do it in a forested setting. It's just a bit trickier.
All right, let's continue with the questions. We've got some here that were submitted online, and if we've got some time after, we can also take a few from the audience. So, and this question is open to anyone. This person would like guidance on altering pruning schedules for berries and fruit trees going forward.
Yeah. So when I first heard this question, the first thing that came to mind is there are some things that we recommend pruning anytime it's dormant. So that for like apples can be, the winter through the spring. But with climate change, I think it might become increasingly important to wait till the end of the dormant period, because we talk about these extremes of like lack of snow cover and all these other things that can impact. You could see a lot of dieback in the winter. So if you prune at the beginning of the dormant season, you might prune out some good stuff and then have other stuff die. If you can wait till the end of the dormant season, you can really see like, what did it make it this winter on this tree and prune accordingly. But I think the bigger thing than pruning is going to be the other practices that are going to give our plants a fighting chance. So in drought years, when you establish, say, a new tree or shrub, making sure you're giving enough water. And in drought years, maybe you're not used to giving your apple tree supplemental water, but in a drought year, consider giving it some supplemental water. Making sure it's nicely mulched, avoiding, the dreaded volcano, which now that I've said it, you're all going to see. So we don't want mulch volcanoes. We want mulch donuts because we don't want the mulch against the bark of the tree. So just other cultural practices that really help the health of the tree, I think is almost even more important than pruning for them to survive. Because our peach specialist said the average peach in Maine lives like 7 years.
I quote, "We know that the Carner blue butterfly appears to be extirpated in Maine due to a lack of sundial lupin," which we talked about. I recently read that another theory is sundial lupin is blooming earlier and so is not available when the Carner blue needs it. Would you please comment on the blooming times of the native plant and how they are affected by climate change?
Yes, so this is a great question. So the Carner blue butterfly, its larval host plant is the native sundial lupin. So that means that the eggs are laid on the vegetation of the sundial lupin, and then the caterpillars eat the vegetation of the lupin. So I don't think it's so much of a bloom time mismatch that's the issue. It's just that they're not around. Even when in areas where there is still sundial lupin, it requires pretty frequent disturbance. It's fire adapted, if I'm not mistaken, which is kind of not a thing that we like to do a whole lot on the East Coast. So and as well as just its habitat in general, just being kind of demolished. So for the Carnet blue butterfly, I think it's more of an issue of, at least in Maine, just there not being any native sundial lupin. The native sundial lupin actually doesn't have any nectar in it anyway, so it's just the pollen that their bees are after, which is just an interesting fun fact. But true though, the question of bloom time changes, and pollinator use of it or pollinator emergence definitely is a big thing. I kind of mentioned this when I was talking a little bit earlier, but there was recently a study across the southern New England area and south on this specialist bee that only feeds on the genus Vaccinium, which is our blueberry species, or blueberry genus. And it was found that the bee, I got to check my notes here actually. Let's see. So the bee, that specialist bee, was emerging earlier in the year, but the vacciniums that it depended on to collect pollen, actually the bloom time stayed consistent, at least in the north. It was the opposite in the south. So the plants were blooming earlier, but the bee was emerging at the same time. So in both cases, a mismatch, but a mismatch on average of about 25 days, which is really significant if you remember that a lot of our native bees are only adults for 3 to 6 weeks. That's like a huge chunk of their adult life that they would not be able to find the native host plant, the native pollen plant that they need. So it's definitely an issue, probably not the issue that's affecting the Carnet blue butterfly, but I would highly recommend, if you can, to try to establish some of the native sundial lupin on your property. It's a beautiful little plant, and it definitely needs some help in Maine too.
We have a question about ash, specifically black ash and white ash, and are they destined for death by ash borers? Do they have a chance?
They do have a chance. This was about seedlings, correct? So back to my point of kind of the self-fulfilling prophecy. So emerald ash borer, it is one of the trains of thought is that it is slated to kind of work its way through the ash population in Maine, but in areas where it's previously the emerald ash borer infestation is further along, they have found, and not sure why, pockets of ash that survived, and that's mature ash. One of the other kind of thoughts is that this younger cohort in the understory, the advanced regeneration, these seedlings and saplings are slated to the borer only goes to a certain size tree, kind of like whole sized and up. So they are essentially kind of blind to that younger cohort. So waiting, that's the hope that once they work their way through and they eat a lot of the food source, i.e. the different ash species, that there is going to be less food, so the population may not disappear of the emerald ash borer, but could decrease, and then that provides more opportunity for the next generation of ash to come up. So not a lost cause by any means. If you see ash, that shouldn't be get it out while I can. But another great resource to reach out to is the state of Maine DACF, or their entomologists are great. They do a lot of outreach. If you're not on one of their listservs, they give updates on emerald ash borer and a lot of the other pests and diseases pretty regularly. And if you want to know how to find that, I can include that afterwards. But it's just another great kind of more regular resource. And if you don't hate email blasts every once in a while, it's a great way to learn about what's happening and brush up on a lot of those resources. But no, not all is lost.
We have time for one more audience question. I saw you first. So sorry.
Can you all talk about native species versus foreign species or whatever? I've always sort of lived by the idea that diversity here is strength. And I'm wondering if there's any positives in thinking about non-native species in Maine. To think of lots that we get benefits of wildlife animals and bears, or if not even native to this continent, And then we're talking about crosses and Chinese chestnuts and American chestnuts and West Chinese. Where do you feel it's fall in terms of that non-native versus natives and cover and those non-native species versus
Yeah, it's a great question. And just a couple thoughts for one. So I live in Portland, and one circumstance where a non-native species could play a great role is a street tree from time to time, or a cultivar specifically, in that street trees often are in the most extremely adverse growing environments possible. And when it comes to urban heat island effects and whatnot, shade is just a huge component of what the street tree provides. So that's one situation. And as far as apples and other things, I think apples, being in the rose family, tons of insects still eat them, even though they're native to Central Asia. So that is a species that, I mean, you could say it's somewhat, it loves Maine so much that it's almost invasive, but it's not technically grouped as an invasive. But yeah, certainly lots of wildlife benefits for apples in particular.
And I've been hearing a lot more interest in an agroforestry realm, and that's a really interesting space where some of the more southern species, whether it's from a forest farming sense, like or in a more traditional ag, like silvopasture, alley cropping, some of the more economic species that you see getting used, like walnuts, hickories, pawpaw, things like that, that have more value down there, and that's why you see more of those practices. Seeing an opportunity for that in Maine with the changing climate, because they usually can't develop here, but seeing a change as things change. So that's one kind of benefit, I guess, is that increased opportunities in that sense using typically non-native species. And I had a forestry one, but it's now escaping me. So.
All right. Before we finish up today, I would just like to go down the line and ask our panelists one thing that folks in the audience can go home today and do to make a positive climate impact.
Probably a number of different things, but I think in general, you can, if there's an action group that you would like to join and that advocates for policies that will reduce dependence on greenhouse gases and make positive changes in that way, and that's one avenue. And so we can all make choices about how we consume energy, how we travel, and how we consume. And so there are many things we can do at the personal level, and then of course there are through joining advocacy groups we can shape policy. And then for adaptation, there are things you can do to help strengthen or make your property more resilient to heavy precipitation events, and there are resources available for that. So I listed more than one, but
I'm also going to give two, and these are both, I guess, personal things that you can do. Number one, on the topic of volunteers, I do a lot of habitat restoration things, and we need people to help plant just, during the day. So if you live near, a land trust or another organization that is looking to do some habitat restoration, volunteering with them for your time, it's very much appreciated. You will be helping contribute to biodiversity in your local area, contributing to resiliency, especially for our native wildlife and pollinators. So definitely you can volunteer your time. Another thing I would say is get rid of some of your lawn. If you have a lawn, replace it with some great pollinator species, some native plants. You don't have to get rid of all of your lawn. I know there's definitely uses for it, but reducing the size, stopping using a lot of pesticides if you currently do on your lawn, fertilizers as well. Just kind of scaling back a little bit on the lawn would be my big thing that you can do personally on your own property.
I also have two. The first being Just get to know your space in your community. If you're a landowner, walking around your property, people's eyes on the grounds is one way that invasives get found, or like changes can be found. If you aren't a landowner, just doing that in public and green spaces near you, just getting to be familiar with spaces around you and noticing those changes is a great way to help enact change if you're the eyes and the ears on the ground. And then the other one being, it's never too late to kind of cultivate an appreciation for the outside and the environment in folks. So it doesn't have to be inundating them with reports and like climate doom and gloom. It can just be inviting them out to a green space and like starting that relationship there. So that's a great way to get someone else into the action without kind of scaring them away at the onset. So.
Yeah, couple thoughts. One, just that I think in the face of climate change, Maine is going to continue to be a desirable place to live. And so I would advocate on the local level for smart growth. And while our Bring Nature Home program is focused on what you can do in your own backyard, I think where your backyard is does matter, and to make sure that our development happens in the most sustainable way possible. And that's not advocating for discouraging housing. We need a lot more housing, but in the right locations. We have all these beautiful downtowns and village centers across the state that it could be much more walkable. So on the local level, try to encourage growth where it should be happening. And then just plant a tree that will outlive you.
To add, Hannah, to your lawn reduction thing, I recently heard the philosophy that lawn should be area rugs, not wall-to-wall carpet when you're designing. So it's fine to have some lawn where you need it and where you use it, but shouldn't be everywhere. So my action when you go home is hoard carbon. So in your garden, your lawn clippings, don't get rid of your lawn clippings, don't get rid of your leaves, don't send your brush to the town. In a native ecosystem, that stuff all falls and replenishes the soil and is food for the soil microorganisms that break it down, and that's more carbon in the soil. It's going to make it's going to be a mitigation because you're increasing carbon sequestration, but it's also an adaptation because it's going to make your soil more resilient. So yeah, hoard all of your carbon. Like when Lewiston we had that big storm and I saw people pulling out their brush, I was like, oh no, I'm keeping all my brush. I'm building dead hedges for the wildlife. I'm chopping and dropping things back into the soil. So that's my action. Keep all your carbon. Unless it's an invasive, and then you can bag it and trash it and or burn it with a permit.
Great. Well, those are some excellent concrete actions that every one of us can take. When you're looking at climate change, it is an extremely heavy, taunting topic, and it can be easy to get discouraged and lose hope. And considering it has far-reaching implications. But as we've just heard in the last couple of minutes and throughout this entire presentation, there are things that every one of us can do. And you might be thinking, well, if I go home and do this, I'm just one person. What does that accomplish? But I don't think that is the case. We talked about climate change as a threat multiplier, and I believe that the inverse is true, that we can make positive change in an exponential way as well. So go home, plant that shrub, hoard your carbon, shade out your wetland areas, and people might take notice. Folks that you know, or folks that are just walking down the street, walking their dog, if they see that, they see change taking place, they can go home and do that as well. And the positive impacts just stack from there. So if you take anything from today, it's that any one of your own actions can have far-reaching implications of their own. Thank you very much. Our panelists will be here for another couple of minutes, so if you have any questions that